Okay, so in this little video, we're going to be looking at this application problem about profit. If I can find my pen, which I can't. Oh, here it is. This is a pretty typical type of problem from a business course, an economics course, etc., where we are looking at profit. Profit has a pretty simple definition. You take the revenue or the money incoming and you subtract the cost of whatever your business cost, products, labor, etc. So we could write it with variables or with function notation as profit. The profit function is the revenue function minus the cost function. So the revenue and the cost can both depend on some variable or many variables. We're just going to look at one in this case. Maybe this is the amount of items sold. So as you sell more items, your revenue would increase to a point, and as you sell more products, your costs would also go up because you're having to produce more products. So that's why these are functions that can change based off of how our x changes. And so it stands to reason that if our revenue and our costs are changing, then the profit would be changing as well, which is why we need a function for that. So it says we're just going to take our revenue and subtract our cost. They gave us the revenue function, and they gave us the cost function. So let's do just what it says. Let's take our revenue and subtract the cost. So revenue, 58x minus 0.4x squared. And then from that we subtract the cost function. So minus 4x plus 13. I strongly recommend you put that in parentheses, because when you subtract a function, you need to change both of your signs. Writing in parentheses is an easy way to help you remember to do that. Alright, so in order to get rid of this set of parentheses, we need to distribute our minus sign, or if you prefer, you could think of this as being a minus 1. So we're just going to multiply that by each of our terms here. So then we're going to get a minus 4x and a minus 13. If one of those had been negative, well, multiplying it by another negative would have made it positive. But in this case, they were both positive, and so now they're both negative. Our other terms, the 58x and the minus 0.4x squared, we just carry down, and then we look for our like terms. Alright, so I'm going to start with my highest degree, degree 2, or the term with an exponent of 2. I only have one of those terms, so I'll go ahead and carry that down, so minus 0.4x squared. Next up, I want to go to my degree 1. So these are the terms with x raised to the first power, or just x. So those are 58x and a minus 4x. 58 minus 4 is 54. So a positive 54 or plus 54x. And then our last term is the constant term, or the number term that doesn't have a variable. I only got one of those, this minus 13, so I carry that down. And we've done it. We have defined we've come up with our profit function, and we've simplified. Alright, so kind of a recurring theme here is that the purpose of naming our functions is so we can refer back to them later. The reason functions are powerful and useful tools is once you've got that function, you can see how it changes for different inputs. And you can do this at any point. A year from now, you still remember your profit function, you could always use it to estimate what your profit would be based off of some inputs. In our case, we're first asked to find R of 70, so that we've got to look at our revenue function. R of x is 58x minus 0.4x squared, and we're being asked to substitute in 70. So now this will be 58 times 70 minus 0.4 times 70 squared. Now I see this issue a lot with students. Make sure you're doing your exponent first. I mean, everyone remembers hymnos. Almost every student I've encountered, is familiar with this concept, but they forget about it when they're actually doing it. We need to do our exponent first, and then move on to multiplying this 0.4. So exponent, then multiplication. Of course, if you're doing it with a calculator, you can do it all at once, but you need to be careful with how you input it. I'm going to do 58 times 70 minus 0.4 times 70 squared. Now, this calculator should be interpreting this correctly. It's going to take whatever I've got in my parentheses and raise it to the second power. There are plenty of other ways you could input this with this calculator. I could have put the square inside of my parentheses. That would also raise just the 70. I work this out and I get 2100, which seems pretty high. I guess when we're talking about a business, this is kind of reasonable. Bringing in $2,100, I guess a fairly small business. Maybe a snowball stand. All right, next we've got our cost function. We're being asked to evaluate this at 70. So we've got our cost function up here. It's 4x plus 13, and we're being asked to substitute in 70. So 4 times 70 plus 13. We punch that all in our calculator. 4 times 70 plus 13 is 293. And then finally, part D, we're asked to evaluate our profit function at 70. So we've got our profit function. It's the only one we haven't used so far. 0.04, a negative 0.4 x squared plus 54x minus 13, and I'm plugging in 70 for my x there. So this will be negative 0.4 times 70 squared plus 54 times 70 minus 13. Hopefully I can get all this in my calculator correctly. 70 squared plus 54 times 70 minus 13. And I get 1807. So I've got all these values. I found all the values they asked for. I want to do a quick check just for funsies. Excuse me. Since our profit function is our revenue function minus our cost function, this should hold true for any value that I plug in. So if I'm plugging in 70 for each of these, I should still get a nice balanced equation here. So I'm going to plug in all the values I got. For P of 70, I got 1807. That should equal R of 70, which was 2100, minus C of 70, which was 293. So I'll do that calculation really quickly. 2100 minus 293, and I get 1807. So I see that my right side does equal my left side. So it looks like I've done all my calculations correctly.